Why is it dark at night? It's not too complicated. Question, you say. But we are not talking now about the change of day and night due to rotation our planet around its own axis. In fact, if you think deeper, the darkness of the night sky becomes not so much obvious. Remember that our universe is trillions of stars scattered almost evenly in all directions, and such a huge amount of radiation should illuminate the night sky quite well, and so much so that we don't have to at all to think about day and night. So what then? What's the matter? You think everything is simple here. It took astronomers several centuries to understand what the matter is, and the cause of cosmic darkness is amazing. Brings us to the fundamental nature universe. My name is Ivan. This is the channel universe.uaua. Congratulations. Imagine standing in the middle of a large, dense forest. We assume that it has some limits or extends so far away that it is difficult for us to comprehend these boundaries. What will you see in such a forest, except trees? If you shoot an arrow in any direction, it is necessary would hit one of the trees if you hadn't tried to avoid them. Of course, provided ignoring the Earth's gravity, because there is another option, is that the arrow will simply fall. The abstract situation only forces us to realize that if the arrow were not far away arrived, it will bump into a tree, because the trees in the endless forest, they cover our entire horizon with a solid wall. Now imagine that our universe also infinite, and the stars in it scattered over an infinite distance, approximately evenly filling the space. In this case, it is very logical to expect that every point in space always has contained the star. Just like with trees' forest, the stars should be covered with a wall the sky. Every line of sight eventually will cross the luminous object. This means that there can be no gaps that we see with our normal gaze at the sky. But there may be no dark spots on famous panoramas from space telescopes. The sky should be as bright as, and the surface of our sun. So why don't we observe this? Your intuition probably tells you very quickly, suggested what the explanation might be. Likewise, astronomer Thomas Digges in the 15th century, I also did not see any riddles. He may have been the first to suggest that distant stars were simply too weak enough to illuminate the entire starry sky. And this really logical, because with the distance of the star really fade. Or rather, their apparent brightness falls off with the square of distance from our planet. Stars that twice as far from us, they seem to be 4 times less bright, and the stars are 3 times, 9 times darker at greater distances, and so on. But in the 15th century, Swiss astronomer and physicist Jean-Philippe Deschazeau showed that this does not solve anything at all problem. We must not forget that with increasing distance from us, the volume of visible space increases, and therefore, the number of stars increases, which shine in our direction. The problem? It doesn't disappear anywhere. It's very simple. Visualized using Shell's geometric abstraction, which suggested Deschazeau. He imagined that the stars distributed in separate concentric shells around us, like bulbs, layers that extend further and further into infinity. Deschazeau suggested that each star has approximately the same brightness, and the concentration in the universe is also approximately the same. Of course, we know that both the assumptions are somewhat rough, but for the purpose, they are not critical for this experiment. So the first shell is located from 1 to 2 light-years away from us, the second from 2 to 3 light-years, the third from 3 to 4, and for all the following by this principle. Now, I think it's pretty obvious the more distant the shell, the larger it is, that is, the larger its volume is. Therefore, a greater number of stars in its... In fact, since the shells have the same thickness, number of stars inside them grows proportionally square of the distance from our planet. This is interesting because, as we remember, the apparent brightness of stars decreases with similar mathematical principle. That is, the number of stars increases proportionally the square of the distance, and their brightness decreases proportionally to the square distance. As a result, it turns out very interesting picture. The stars in the nearest shells will be brighter for us, but their number is smaller. Instead, the stars in distant shells will be dimmer, but their number is greater, and in essence, it compensates for the dimness. In fact, mathematically, each subsequent shell will seem to us as bright as previous. It turns out that each subsequent shell makes the same contribution to the overall brightness of the sky, as well as previous. Therefore, adding more shells, you get more and more light and an increasingly bright sky. Obviously, the brightness decreases with distance still doesn't solve the problem. If the universe is infinite, our sky should be as bright as the surface of the sun, and we would never know about day and night. Deschazos' work brought scientists back to ideas of Johannes Kepler, who at the beginning of the 10th century claimed that the universe is finite in volume. Thanks to modern astronomical observations, we know that this is not entirely true. We do not observe the visible universe traces of some land. Perhaps then it's about the distribution of matter in the universe, because we have star clusters and galaxies eventually. But in reality, it does not have much importance. Since itself, the distribution of galaxies can be viewed as almost uniform throughout the universe. Wherever you point your finger in the sky, you have to hit the galaxy. In 1823, German astronomer Henry Olbers tried to thoroughly consider this a problem that was later named after him, Olbers paradox. In his article, he confirmed that the dimness of the stars is not help solve the mystery, so suggested dust and gas as a potential explanation. He claimed that gas and dust clouds can simply block light from distant stars, or, in more modern version, from distant galaxies. What Olbers did not realize, this is the ability of dust and gas not only absorb, but also ultimately radiate the absorbed energy. If the universe has existed for quite some time, then dust, absorbing radiation, eventually will return it back to space. This means that space will still be filled with the amount of radiation itself. If you want, the dust will simply act as a mediator. It will shine no less brightly than the stars or galaxies that eclipse. So the reason is different, but what is it? Well, the real reason for the darkness is simpler, but at the same time much deeper than any from the proposed solutions. It's all about because our universe had a beginning. Strange, but for the first time a reasonable answer. It was not given by an astronomer or even a scientist. It was Edgar Allan Poe. In 1848, year after year before his death, he published a famous work entitled Eureka, a prose poem. In it, Poe described your intuitive understanding of nature universe and, among other things, suggested that the universe is simply not old enough to fill the whole sky with light. He believed that space can be infinite in size, but first, its existence. Not enough time has passed for the radiation from its most remote corners have reached us. An amazing example when a person without appropriate education exclusively intuitively reached a cosmological conclusion that in just a few decades it will become dominant in science. Today we know that has passed since the Big Bang about 13.8 billion years. And what's really amazing is, how much is this, astronomically speaking, a short period of time? Think about that, only our star will shine near 10 billion years old. Even though it is now, it's almost 5. The age of the universe so small that outside the bubble only 13.8 billion light years. Photons, they still fly to us. So that's good question. How many stars and galaxies do we have? Visible in this bubble that we call visible universe? That is it enough them to fill every line of sight? Well, you can calculate it, or even simpler find a ready-made calculation on the internet. Thank you, Mr. James and Mamura from University of Oregon. So we have to go again. We need to go back to the cosmic bulb. As we understood, the key point that leads to a paradox is that the amount of light we receive from the shell does not depend on whether how far is this shell from us is located. So it is natural that each of them adds its contribution to the total, the brightness of the sky. The more shells, the more light at night. Now you can calculate how many shells are needed so that the whole sky is as bright as surface of the sun. We assume that the average density of vision in the observed universe is approximately equal to 1 of light per cubic parsec. This, to words, a bit of an overestimation, but it's convenient for simplifying calculations. Parsec is about 3.26 light years. For a better idea, distance to the nearest Proxima Centauri is approximately 1.32 parsec. So, on average, we assume that the stars are spaced apart by a distance in 1 parsec, and therefore the thickness of each. The shell can also be taken as 1 parsec. So Mr. Imamura calculated that for night to become day, it is necessary about 2 to the 10 to the 15th power shells around our planet, or 2 million billions of shells. Is a lot? Since each shell is long 1 parsec, then we can easily estimate the size of the universe with so many shells. Its radius should be the same 210 to the 15th power of parsecs. If we convert this as in usual light years, then we get radius as 6.6 by 10 to the 15th power of light years. The universe has a radius of almost 7 million billion light years, or cm quadrillion light years. That's how it should be. Space and size, so that night never was dark. This is, to put it mildly, a bit larger than the observable universe, at 480,000 times more. I remind you, this is also underrated because it's real the concentration of zero in the universe is even lower for 1 per cubic parsec. So here it is, the real reason why we still see the darkness of space. It consists in the fact that we only see a part of the universe. He's just too young, and the speed of light critically small so that we can see more. Now some of you are probably thinking, why didn't this Ivan say anything about red SUV? After all, its influence also has to be noticeable on the overall effect, the blackness of space. This is true. The expansion of the universe leads to a loss of energy photons. Ultraviolet starlight, traveling billions of years through space, which expands, loses energy, and reaching us becomes, for example, infrared. Such light, of course, is not available to imperfect human eye. Therefore, distant galaxies are dimming not only because distance, but become less bright through the cosmological redshift, which caused by expansion. In fact, it is only partially affects brightness sky. Its role is not so significant compared to the limited time of existence, the universe itself, and extremely slow speed of light. However, this role. The red scroll will become larger and larger. The universe is evolving. It continues to expand and even does it with acceleration. Therefore, the role of expansion will become increasingly dramatic. It is through the expansion of our sky. Perhaps it will never be brighter than today. Think about it. If our universe was static, then its apparent size would depend only on time. That is, what more time has passed since the big explosion, the more photons will reach us from more remote corners of the universe. The visible part is now 13.8 billion light years in every direction. After 20 billion years since the Big Bang explosion, the radius of the universe will increase to 20 billion light years. After 100 billion, in a few years, it will be 100 billion light years. So a static universe in 7 quadrillion years would be exactly like this big, so that all the stars in it will see us finally blinded. But this is where the factor comes into play. Extension. Main feature the scattering of distant galaxies is because the further apart they are, the faster they escape. Galaxies for 1 megaparsecs are moving away from us at speed 70 kilometers. Galaxies 2 megaparsecs away at speed 140 kilometers, for 3 mega-apiaries 210, and so on. So there is the distance at which objects move apart from us at a speed of 300,000 kilometers per second and even more. Yes, objects with deep space can escape us faster than light. And if you're confusing, watch my video, what devoted to this topic. The main idea is that fundamental property of the universe, which is related to expansion, won't let all the light from all the stars in and galaxies reach us. There are areas of space which are far beyond the visible the universe, and the light from them simply will outpace the expansion itself and never will reach our eyes. This is called cosmological horizon, and if more specifically, the event horizon. We will not know what lies in those distant lands, invisible corners of the universe, which expansion is moving away from us faster than light. Our sky is never illuminated by stars from those areas, and therefore our nights will be dark. Moreover, because of expansion that does not stop, and according to, with modern estimates, never will stop, even galaxies beyond local gatherings will be outside our vision. With the naked eye, and even using the largest telescope we will observe only our own stars' galaxies and several neighboring ones, if they will not merge into one. For the astronomer, the night sky will be darker than it is now. But it will happen someday. Someday very, very soon, not soon. Right now, it really surprises me the simplest possible astronomical observation. I mean, simple. A look at the night sky gives you the key information about the universe. It's a fundamental property. Usually, when astronomers are asked about evidence Big Bang, they talk about a few important but standard things. For example, about cosmic microwave background radiation or something like that, an expansion that had to start somewhere. But here is the simplest proof. Right there, us in front of our noses, and everyone can see it. See with your own eyes. If the universe were infinite in time, that is, eternal, you would, if you hadn't seen the night, you would have seen a constant day. Therefore, if anyone seeks evidence Big Bang, you have to go outside in the middle of the night and to contemplate the darkness of space. Thank you, friends. If you like what you see, What Am I Doing? Please support this release with a like and comment.